Hi, this is Algebra 1, Module 6, Lesson 6, the practice problems. We are seeing how lines are transformed given the different equations we have here. So if I were to draw the x plus 3, we'll do that one in green. So I'm just going to do a little green line here. We'll do the green here. So if I have x plus 3, 3 is my y-intercept, and my slope is a up 1 over 1. So it's going to go this way here. And this one, notice I have my original line in there. 1 down, 1 over 1, back one. So this is the original. And I'm trying to see, um, for each new equation, explain what the number 3 does on this graph compared to here. So pay attention to the y-intercept, x-intercept, and the slope. Let's say what changes. And we're using green for all these. So for this one, the slope is the same. Notice they're both going up 1 over 1 to go on there. And output values are 3 higher than they were before. So if this was 0, instead of 0, 0, it's 0, 3. Instead of 1, 1, it's 1, 4. 2, 2, 2, 5. They're all 3 higher than they were before. All right, let's do blue for the next one. X minus 3. Do this one in blue. So that means I'm going to start at a negative 3. 1, 2, 3. And I'm going to go, oh, that's a 2. Just kidding. Undo. 1, 2, 3 down here. Ugh, why is it doing that? Is not where I clicked. All right, there it worked. Okay, so up 1 over 1. My grid boxes are a little weird shaped, aren't they? So there's that guy, and then I'm going to start here again, and we're going to go the other direction. All right, so this one, let's see what we're doing differently. So again, my slope is the same. I'm still going up 1 over 1. This time, the output values are 3 lower than they were before. So instead of 0, 0, it's 0, negative 3. Instead of 1, 1, it's 1, negative 2. Instead of 2, 2, it's 1, negative 1. So it's 2 lower than the ones before. All right. Oh, let's zoom back in. Okay. Next, let's do purple. So we'll do purple with this guy. So for here, I need to do 3x. So I'm actually going to start at 0, 0 because there's no plus or minus on the end. But I'm going to go up. Oh, why is that blue? I thought I said purple. Purple. All right. Start here. Up 3 over 1, up 3 over 1. And then I'm going to do it again, going down, down 3 over 1, down 3 over 1. So notice what this line is doing. This time the slope is not the same. Slope is steeper, shooting up much higher than the other ones. And all output values are 3 times what they were before. Right? So 0, 0 is still the same. But instead of 1, 1, it's 1, 3. Instead of 2, 2, it's 2, 6. It's 3 times bigger. All right, so now let's look at it again. This one over here, we've got again, now we're going to see what the number -2 does to the graph in each of these equations. So go back and do what we did. Um, oh, predict first and then we'll draw it. Okay. So prediction. Here, it's an x plus -2. So I'm going to predict it's going to move all my values. I'm going to say the slope is the same. Slopes are the same. But the output values are 2 lower, because it's -2 down, than they were. All right. So when I graph this with green, I'm going to start at -2. Oh, I clicked something. What's going on? Undo. Start at -2, and I'm going to go up 1 over 1. And sure enough, it looks like all my values are 2 less than what I originally said. It's going to be a little off because I didn't quite get in the corner there. So down 1 over 1. Boom. About like that. All right. I was a little off on that. Anyway, next one. Prediction. Let's do our blue here. So here's a minus a -2. Well, minus a negative is really a positive. So again, I think the slopes are the same. But this time, I think the outputs will be 2 higher than before. Okay, let's go ahead and draw that. So x minus a negative puts me up here at the positive 2's. And I'm going to go up 1 over 1. And again, down that diagonal. There, I'm right. Okay, so now my prediction for this one is, so this one I think the slope will be downward, downward to the right. I think this one. And when I go to draw it, I'm going to start at 0, 0, because there's no plus or minus there. And it is a down to, oh, that is not the right spot. That's too far off. Okay, we need to get closer to center. Down 2 over 2, down 2 over 2. There we go. And then try to hit that again. Up 2 over 1, up 2 over 1. And so there it goes. It crosses the other direction, down to the right. I'm correct. Good deal. All right. Now we're going to distinguish between linear, exponential, and quadratic functions. So for each relation, we need to identify whether it is a function or not. Determine if the function is linear, exponential, quadratic, or neither. So they're listing them all out for us. Describe the type of growth, so what's doing, and then express the relation in the indicated form. So this one is saying I had 81 freckles on my nose before I began using vanishing cream. After the first week, I had 27, the next week, 9, and 3. So is this a function? I believe so. It's like there's only one value for each one I'm doing. Linear, exponential, or quadratic. Well, it's going from 81 to 27. That's a divide by 3, divide by 3, divide by 3. So if it's a divide or a multiply, that would be exponential. How does it grow? It is, oh, so the growth, it's not actually growing. It's actually, it is 1/3 previous week. So it's going down by 1/3. So it's not technically growing. um, third the value of the previous week. Make a graph. Label the axes in the scale. Show all 4 points. So if I have to get up to 81, let's see here. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Basically count by 10. So 1, 2, 3, 4, here's 50, 60, 70, 80, 90, here's 100. And this will be freckles. And then down here will be some weeks. Weeks. Oh, I probably wrote that too close to it because I need to be able to put my numbers on there. Yeah, but count by ones, right? So 1, 2, 3, 4, 5, 6. I think that'll give us enough. And this is weeks. Okay. So I need 0 and 81. So that was 90. So here's about 81. And then after the first week, I had 27. So 10, 20, 30. So 27 is going to be right there. Second week, I had 9. That's right below the 10. Third week, I had 3, which is down here. Fourth week, I would have had 1. So, and fifth week would have even been a third of 1. It's a little guy. All right. So there I did my graph. Next. Okay, 81, 81, 80 and 2/3, 80 and 1/3, 80. Looks to me like it's a minus 1/3, minus 1/3, minus 1/3. Okay, so is it a function? Yes, it is, because we are subtracting each time. Linear, exponential, or quadratic. If it's a subtraction or plus a negative, that would be linear. How does it grow? Well, again, it's not really growing. It's decreasing by 1/3 each time. Then write an explicit equation for this one. All right, well, an explicit equation would be f of x equals, well, I'm starting with 81. So 81, and I'm subtracting 1/3. I'm going to go ahead and put that in parentheses since I have to do it sideways here. And however many times I do that, I'm starting with my 0 term, so I can just do minus 1/3 x. All right, next one. Is this a function? Well, if I'm looking at this function, I see points that are combined here. So, no, this does not look like a function, which means it is neither. We don't really have a way that it grows, but at least I do know that 0 is 0. 1, and to prove it's not a function, 1 could be 1, 1 could be -1. Therefore, it is proof it's not a function. All right, speed in miles per hour of a baseball versus distance in feet. So it looks like I kind of have a chart over here, maybe a graph going on. So it looks like it's a function. There's only the one line there. So I'm going to go ahead and put yes. It looks, I'm looking through my points. It's really hard to see these guys. Let's see if I can zoom in a little. Oh, that's a little better. Okay, so every 5 I'm going up. So this one is 75 minus 47 would be 28. This one is going up 27. This one is, let's see, 29. And this one is 30. So my first distance, that's not linear because they're not all the same, but these are all 1, which means my second difference is consistent, so that would make it quadratic. How does it grow? Well, I don't really have much space over here. I'm going to type it over here on this side. So its growth, it increases more each time, um, since the first difference is linear and the second is constant. Okay. And then predict the distance the ball flies if it leaves the bat at a speed of 115. So if I were to continue going up here, this would be, zoom in again. So that's a plus 30. This is plus 31. If I'd go up another 5, that means this would, excuse me, go up 32. So 65 plus 32 would be 397. So my prediction, that just a little smaller again, will be 330, 60 plus 3, yeah, 90, 97 feet. Okay. All right. I'm going to zoom back out to my normal amount here, 150. All right. I think we've got one more page going on here. All right. Match the function on the left with its equivalent on the right. I should probably zoom out a little bit more for this one so I can see all my different options. Okay, so negative 2x plus 5. Okay, well, here is a plus 5, negative 2x. I'm going to say it's D on this one. Now, I do notice that this is 5 with a slope of negative 2, but it's discrete, and nothing here shows that it should be discrete. So I'm going to do D on this one. All right. Um, 8 is a quadratic equation. So, in looking at my options over here, it kind of looks like this is my only quadratic because that's an x times an x. Talk about that next unit. Here is an exponential. Um, that starts with 1, and I'm subtracting. Oh, here's a double. Here's a couple of doubles. Maybe I'll skip this one for the moment and just kind of see. Or I could plug in a number. Let's see, 0. If I plug in 0, 0 minus 1 is negative 1. 0 plus 3 is 3. So 0 would be negative 3. Well, that one works. Let's try a positive 1. 1 minus 1 is 0. Anything times 0 is going to be 0. Oh, looky there. I'm going to go ahead and put in F because both of those points work so far. We'll see if I have to change anything later. All right, 9. I put 7,000 in a savings account that pays 3% interest compounded annually. I plan to leave it in the bank for 20 years. The amount I will have then. Well, in looking at my various equations, here I see a 7,000. That looks like it's a 103%, which is what I'd want to do for 20 years. So I think this one is G. All right, the area of the triangle below. So area would be half of the base times the height. Well, it looks like I'm starting with, no, that's not going to be a half of the base times the height. That's not really 1. Let's look at here. 1 equals 2. I zoom in here. I think I can see that this is a 2 down here. And so f of the next one is the current one plus 2n times plus 2. Plus 2n time plus 2. Well, let's see. Half of the base is 1 times height, which I think is 2. That's 2. Half the base is 2 times height is 6. 3 times 4 is 12. Where's that a 5? It's like they're all, that looks like a 6. Half of the 6 is 3 times 4 is 12. So if I start with 2, and I add 2 times 2 plus 2, oh, I get 6. Okay, and if I do 3 times 2, which is 6, plus my third, 3 plus another 2, I'm thinking it's this one right here. I'm going to put a C here and we'll see if I agree by the time I'm to the end here. All right, f of 0 is 5. So f of n is 2 times my previous. Oh, or f of 0 equals 5, and I take my previous minus 2. All right, so which one is a times 2? Which one is a plus 2? I think that's these guys up here. Well, this one is definitely a times 2, so A is going to go with the times 2. And then my graph up here, we had the slope of losing 2 each time, and that would be discrete if it's a recursive function. I think this one is B. And so that leaves us with E on here. So x plus y equals 0. Are these opposites? Negative 7.75 plus 7.75, does that equal 0? Yep. Negative fourth plus a fourth equals 0? Yep. I think we've got them. All right. That's all of them for today. Thanks for joining us. See you next time.